Hello guys, my name is Timothy Joseph and I welcome you specially to my YouTube channel where I teach mathematics. In today's lesson, I'm going to teach you the rules of surds with examples. So after watching this video to the end, you should have learned the rules of surds and how to apply them. In this video, I don't want it to be too long, so I'm going to concentrate on the rules of surds and also addition and subtraction of surds. And after that, I'm going to do another video where I'm going to show you rationalization of surds and also conjugate surds. So please stay tuned to this channel so that you can get notification of my new video. Thank you. So without wasting much time, we are going to start the lesson. So let's take rule one, rule number one. I'm just going to write to show you. So rule one. When we have roots PQ, this is equal to root P times root P, root Q rather. Yes. So root PQ is equal to root P times root Q. And then rule number two says when we have root PQ root P divided by Q is equal to root P over root Q this. Then rule number three. Rule number three. Root P plus Q is not equal to root P plus root Q. Please take note of this. Yes, it is not equal to. And then rule number four. Rule number four. The subtraction of root P minus Q is not also equal to root P minus root Q. So take note of this, provided both P and Q are positive. So we can have, when we have, for example, the positive example. So let's look at rule number one. Example, if we have root 12 for number one rule, it means that we can further simplify this by saying, looking for their factors by saying root 4 times root 3. This is according to rule number one, so which is equal to 2 root 3. See this. So this is going to be the answer. Or you can say 6 times root 6 times root 2. But of course, root 6 it's not the perfect square, so unlike 4, so 4 is the appropriate number to use. So also, if we have that of rule number 2, this one, if we have, let's say, roots 16 divided by over 2. So let me extend this root. Okay, is so this is also equal to root 2, sorry, not root 16 divided by root 2. Of course, this can cancel this, so we should have root 8, and then we can further simplify this by saying root 8 equal to root 4 times root 2. And then we are going to have the square root of 4 is 2. We're going to have 2 root 2. So this is example here. All right, let's take another rule, which is called basic forms of surds. Basic forms of surd. Basic forms of surd. So for instance, if we have, let's say we have root A. So root A is said to be in its basic form if A does not have a factor that is a perfect square. Yes, provided that A does not have a factor that is a perfect square, we say that it is in its basic form and cannot be broken down either into two factors, where one of them has a perfect or an exact square root. So this type of root is in its basic form. So let me just give an example so that you can have a better understanding. Roots in their basic form. Example, if we have root 3, these roots cannot be broken down into two factors. That one factor will have a perfect square root. So we say that this root 3 is in its basic form. Root 5 is in its basic form. Root 2, it is also in its basic form. Root 7 as well. Root 11, yes, root 11, and so on and so forth like that. So because they cannot be broken down into factors in which one we have, in which one is going to be a perfect square. So we call this type of roots basic forms. So they're in their basic forms. But if they can be broken down, they are not in their basic forms. For example, it can be broken down if we have like roots. Let's take root 28 now. Root 28, we can break it into two factors such that one will be a perfect square. That is 4 times root 7. So this is going to be 2 root 7. This is in basic form now. Okay, so this has been simplified. All right, let's look at similar surds. Similar surds. Surd, let me just write it here. Similar surds. That is another rule that you need to learn. Similar surds. Okay. Surds are similar if their irrational parts contain the same numerator. Yes, surds are similar if the irrational parts contain the same numerator. What does that mean? If we have 2 root A, yes, and we have 5 root A. So these root A and root A are the irrational parts. So and they are the same. So it is we are going to have something like this. Root A equal to root A. So these are similar sorts. So let's take example. So I need to clean this screen. For example, this so that we can have a better understanding. Similar sorts. Okay, I should have just selected all these guys and take them out. But it's okay. I think I'm enjoying what I'm doing here. Right. So let's take an example. For instance, if we have 6 Let's say you have, so I'm saying example 6 root x, and what we have again, let's say 3 root x. So if you have something like this, so this is basically equal to root x, equal to root x. So yeah, root x equal to root x because they are common. Okay. If they are in numeral form, you have root 5 equal to root 2 and 7 equal to root 2. So we should have, since the rational parts are the same, so we are going to have something like this. So I think we normally apply this in subtraction and addition of surds. Okay, let's take another example. Sorry, another rule. And this time around is called conjugate surds. Conjugate surds. This is another rule. Conjugate surds. So conjugate surds are two surds whose products result in a rational number. Yes. In an expression containing difference of two squares, it is known that, for instance, when we have an expression like this that contains two squares, if you have x plus y in brackets and x minus y in brackets as well. So this is equal to x square minus y square, right? Uh, in a similar manner, if we have root x plus root y in brackets like this, then we have another one, root x minus root y. You know that it is equal to root x in brackets, then we square this minus root y square as well. And then everything, if we want to simplify further, we are going to have x minus y here. So let me give example so that you can understand. So therefore, the conjugate of let's take example. So I'm going to erase this. For example, now if you have let's say the conjugates of a sort like this. Let's say you have root root 3 minus root 5. So the conjugate of this sort is going to be the positive form. So that is root 3 plus root 5. So this sign changes, right? Okay, so let's erase this part again so that we can have space. I am going to teach you how to apply these rules by using different problems. So just stay tuned to this channel so that you can grab the understanding, right? So let me give another example. The conjugate of minus 2 root 3, which number I should do is now plus root 5 is equal to minus 2 root 3 minus root 5. So take note of this, please. All right. And likewise, so we can basically say that the conjugates of let me write it here. This place is going to be enough words I want to write. No, I want to put it here. Of so let me just put this x, sorry, root x plus root y plus root y is equal to root x minus root y. Then another example, if we have root x minus root y is also equal to root x plus root y. So this is what the conjugate rule says, right? This is what it says. So let's quickly look at a few examples. Let's look at addition and subtraction of surds. Addition and subtraction of surds. As I've said, we are going to consider addition and subtraction of surds in this video, and then in the next lesson we are going to study or learn about rationalization of surds. So addition and subtraction of surds. Let me give an example to explain this. Let's say we have evaluate. Okay, should I just erase the board and then we start all over? I think yes. So if you need to study these rules, you can watch the video again so until you understand better. So I want to clear the screen so that I'll just start afresh from here. So let me put it here. Addition and subtraction of surds. Okay, let's take a few examples. So one, let's say you have to evaluate something like this. Root 32 plus 3 root 8. So you are given something like this to evaluate. So first thing to do is to break down this roots here with 32 and with 8 in such a way that one is going to be a perfect square and then the other one will be in basic root or basic form. And to do that, we will, so let me write solution. So we have root 32, which is going to be 16 times 2. That is root 16 times 2 root 16 times root 2. Yes, because 16 is a perfect square. Then plus 3 root 4 times what? Root 2. Yes, we should have something like this. And then we'll find the square root of 16, which is 4 times root 2 plus this guy, which is going to be 3. The square root of 4 is 2. So we are having something like this, right? 2 now. So now we're having a similar roots now. Root 2 here. Don't forget the similar surds that we consider as surds similar if their relational parts contain the same numbers or numerals. So this and this. So what we're going to do now, so this is going to be 4 root 2 plus 6 root 2, right? 6 root 2. So let's come here. Divide the screen now. So this is equal to 4 plus 6. We just pick one of the roots since they are similar, and then our answer is 10 root 2. This is very simple to solve. Okay, let's take another example. and see how we can tackle it. So we have done one, so let's take another one. Example 2. If you are asked to simplify or evaluate something like this, evaluate root 7, no, 7 root 3 minus root 75, root 75, something like this. So let's write solution, and then we solve this guy. So we have root 7 root 3 minus uh, root 75. So already this one has been broken down. So again we're going to break this guy down in such a way that one is going to be a perfect square and the other one will be in its basic form, which is going to be 3. So to do that, we will say 7 root 3 minus we should have 20 root 25, yes, minus no, not minus. Okay, we can also write this times, so that's 3, yeah. Then we have root 7 root 3 minus the square root of 25 is 5, and then we have 3 here, 3. So this is going to be, since this and these are similar, we just say 7 minus 5 root 3, and then we are having 2 root 3 as our final answer. You can see it is very simple to handle. All right, let's take another example. Let's continue another example. So if we have, this is going to be number 3, so I want to put it here. Okay, so let's divide the screen again. This screen needs to be divided, so let's divide our screen. Okay, so example 3 evaluates, this space will be enough, 3 root 48 minus root 75, and then plus 2 root 12, 2 root 12. So we have to evaluate this guy. So let me change to white now. I want to use white. So we have our solution here. So what we have here is root 3 root 48 rather. Let me write it clearly then, minus root 75 plus 2 root 12. So again, we're just going to break these guys down into their factors. So this is going to be 3 brackets, sorry, not brackets, root 16 times 3. Yes, these are the two factors. You must make sure one is a perfect square in order to get it done. So then we're also going to have root 25 times 3 is 25. Then plus what again? 2 roots 4 times 3 as well. Okay. And now let's take the square root. 3 times root 16 is 4. Then we have the basic form, which is 3 minus root 25 is 5. We have 3 left plus 2 times root 4 is 2 root 3. You can see that we now have similar surds or similar sort with 3 root 3 root 3. So this is going to be 12. So let's just pick root 3 minus 5 root 3 plus 4 root 3. So we are going to pick one now, but we are going to simplify this guy. So we have 12 minus 5 plus 4 root 3. And then our answer should be what? So 12 minus 5 uh, is 12 minus 5. What do we have for 12 minus 5? Is the value of 12 minus 5. I'm asking myself again, 7. Yes, is this what we have? Okay, let's go through our working again to make sure everything is intact. Okay, so 12 minus 5 is going to be 11, sorry, 7, and 7 plus 4 is 11 root 3. And if you want to rearrange the number by saying bringing plus 4 here, which is fine. So you are still going to have the same answer. That is 12 plus 4, 16, and 16 minus 5 is still 11. So here we are getting the answer is going to be 11 root 3. So this is the answer. So this is very simple. So this is where we are going to stop in this lesson because I don't want this video to be too long. As I have promised, I'm going to do the second video where I'm going to cover more problems. I'm going to apply the conjugate sorts rule. I'm going to use rationalization of sorts as well too. So please do like this lesson, comment, and subscribe to my channel for more updates. Don't also forget to turn on the notification bell. So thank you for taking your time to watch the lesson. Goodbye. Till then. So please subscribe. Okay. I mean subscribe to my channel and so that I can join more video lessons like this. So we need to